Hello, and thank you for joining today's Environment and Energy Leader webinar titled Empowering Environmental Technologies with IIoT, sponsored by Angle Environmental Systems in partnership with Siemens. We appreciate everyone joining us live today, and a large thank you in advance to those who will be watching this on demand. My name is Jessica Hunt, and I am the Director of Live Events for E&E Leader. Before I hand the presentation over to the experts, I do want to go over a few housekeeping items with attendees. If you experience any technical difficulties during today's event, please follow the troubleshooting tips located in the Help widget at the bottom of your console. If you are still having issues after following the steps listed, please send a message to me via the Q&A widget, which is already open for you on the top right part of your screen. We will be holding a Q&A session at the conclusion of Chris and Troy's presentation, so if you have questions, please submit over the next 40 minutes or so. If we do not get a chance to answer your question during the live event, one of the speakers or a member of their team will get back to you as soon as possible. Angle was kind enough to provide all registrants with a copy of today's presentation. This document, as well as 3 additional resources, can be found in the resource list located underneath the presentation. And now for today's speakers. Over the past 25 years, Chris Angle has devoted his career to the technical sale and application of Angle's air pollution control and energy recovery systems. As the president, he is currently responsible for both the revenue and profit for this internationally recognized supplier. Chris serves on the environmental committee for numerous trade associations and is intimately familiar with the air and water pollution control needs of industry. Troy Wilson is the team marketing manager for Siemens Cloud Application Solutions. He has served 12 years with Siemens Industry Software, consulting with many companies on the subject of IoT and associated solutions. He is a 4-year veteran of the automotive industry with a bachelor's degree in computer engineering from Rose-Hulman University. And before I hand the presentation over to Chris and Troy, here is a little background on the 2 companies. Angle provides highly engineered environmental equipment and service solutions that help solve complex industrial air and water challenges across the globe, from thermal and catalytic oxidizers for air pollution control applications to custom integrated systems for wastewater treatment. Angle is committed to protecting the environment with unmatched engineering, innovative equipment, guaranteed compliance, and reliable service. Siemens was founded on a powerful idea. A company should not only focus on maximizing profit, it should also serve society with technologies, with its employment practices, and everything it does. As an innovation leader, Siemens thinks ahead to the next level of the digital transformation of integrated cutting-edge technologies. And I think all attendees have heard enough from me. I look forward to a great presentation. And at this point, I'm going to turn the mic over to Chris and Troy.
Thank you, Jessica, and thank you, everybody, for attending today and taking the time out of your busy schedules. My name is Chris Angle, president of Angle Environmental. And on the screen, you kind of see the agenda that we're going to be going through today. IIoT, or Internet of Industrial Things. What we're going to be looking at today is really starting out with some business trends regarding IIoT and specifically the environmental equipment. Then I'm going to turn it over to Troy, talking about some of the technology and the basics and benefits of IIoT. I'll then cover some of the use cases where IIoT can be applied. Troy will then also talk about some of the implementation challenges and techniques that this up-and-coming technology continues to become a greater part of all of our lives in our workforces. And then we'll do some key features and functionality to consider. And then, as Jessica mentioned earlier, we'll really jump into some questions and answers. We'll try to answer as many as we can today. But as Jessica mentioned, we will track all the questions and get back to you, whether it be Siemens or Angle, to support you if we don't get them in our 1-hour time limit today. So what is the Industrial Internet of Things, or IIoT as it's often referred to? At its core, you're interconnecting hardware and software into a single system that utilizes sensors and instrumentation to measure, monitor, and adjust things like industrial processes and pollution control systems. It is technology transparency This connectivity allows for data collection, exchange, and analysis to facilitate improvements in productivity, efficiency, as well as other economic benefits. Making business decisions based on accurate and real-time information is extremely important when dealing with environmental compliance, which we hope to demonstrate here today. As shown on the survey data from a few years ago above, which we still believe still holds true today, 85% of potential assets are not currently connected. However, over 60% of people and companies are considering IIoT. And that really leads us into our first poll question.
Thank you, Chris. Our first poll question, are you currently using IIoT for your environmental systems? Yes, no, or I don't know. We're going to give attendees roughly 10 seconds to answer this before we move on to the results.
Thanks, Jessica. So it looks like we have about 25% are using it, 25% are not, and 50% don't know. And going back to the previous slide, that kind of jives with it. It looks like it's being improved. So if you took the I don't know as no, it's 75%. So this was a couple-year-old survey. So looking at it, it seems that people are heading in that direction, and that's kind of what we're seeing with our clients and our customers moving forward. So thank you for answering so quickly, everybody. So before I elaborate a little further, let's take a little brief look at the history of Industry 1.0 to 4.0. As shown in the graphic above, the Industrial Revolution, where the steam machine came into play, was about an 80-year life cycle. Then we went into the Industrial Revolution of 2.0, where production lines came into play, and that was roughly a 100-year cycle that's went on. Then we went to 3.0, where automation came into play, further advances in industry, and that happened over the past 50 years. But now we're into Industry 4.0, and it's just moving at a lot faster pace than any of these previous revolutions. So what's important to understand about the current revolution we are in, it's the level of complexity is significantly more. Environmental regulations and compliance are also following this very similar pattern. Staying in compliance for air pollutants and wastewater discharge is getting increasingly difficult and harder to track and more complex with the various agencies such as the EPA, the local regulatory agencies, or any international governmental agency that regulates the emissions of pollutants. So during this webinar, we're going to show you how the IIoT will greatly reduce your compliance complexity. Now, we're not here to scare you because of complexity, because we don't want you to shy away from this. If you can embrace it and take it in, we really see this as a competitive advantage for both you, your company, and your customers. So why is it critical now? And before Troy gets into the basics and the benefits, it's important to discuss why it is so important now. Current business technology trends and the state of the global economy are accelerating the need for the IIoT. For instance, baby boomers are retiring now and leaving the workforce at a greater rate with a lot of tribal knowledge that is going away with them. And the global economy it's just a global world. I mean, it's different than U.S. is doing U.S., Europe's doing Europe, Asia. It's really seamless, and especially in our company where we are working with India, China, Southeast Asia, Europe, our supply chain. So having the more data, the more metrics, the more things we can gather from our equipment, the better we can support and serve our customers. Now, when you add in the global pandemic, the need to act now is even more important. Quarantines are forcing employees to work remote. Site employees being gone, so there's less engineers at the plant, less maintenance personnel at the plant. we're being forced to, become reactionary. And instead of being proactive and preventive, it's really put a damper and illustrated the need for this IIoT even more than ever. And I touched on this, the increasing remote workforce. If, like many of you, you're probably listening to this webinar from home right now, although you used to go to an office 5 days a week since last March, it's also common in our company. The question is when we get through this pandemic, and hopefully the vaccine coming out soon, will people come back to the office, or will they continue to work remote? So it's something that we have to deal with. And IIoT can not only help your company survive this pandemic, but we believe it can catapult your recovery after this period. So even before COVID, companies that weren't embracing IIoT were already slipping behind, and there's no way to measure the opportunity cost. So with that, I'm going to hand it off to Troy Wilson, Siemens, who's going to cover some basics of the IIoT before we dig into their applicability to environmental technologies. Troy?
Sure. Thanks, Chris. I appreciate that, and thanks for the good setup. I'm going to go through some of the trends, and while there's some environmental implications into this, there's also just here's why any company might undertake an IIoT. And these are broad topics, but it's worth mentioning, and we see this across any vertical. Production optimization is usually the first one, and that's anywhere from how do I optimize throughput on one line, throughput on one cell, throughput on one factory, or scaling all the way across. How do I optimize one factory in Europe versus one factory in the U.S., or how do they work together? It really is how do I get this modularization, and how do I optimize those puzzle pieces to fit together in the way that I want from a cost, quality, or time perspective. Another interesting trend when it comes to connectivity is the connected digital worker, which is also, Chris mentioned, becoming part of the global pandemic. We've seen people who are connecting their workers to make sure they don't get too close, right? How do you tell, hey, you stay 6 feet apart instead of beeper off or a light off? Also, in terms of that, is connected worker in driving virtual work instructions to a machine. So if they show up to a robot or a piece of equipment, they can just have that available to them as they show up. Supply chain, Chris can hit on that. This has been a huge one, and really the word there is resiliency. Traceability is good, but I think given the last 8 months, 10 months, it's really resiliency. And how are you flexible? How do you make sure you maintain a supply chain if something goes wrong on a global scale? I won't spend too much time on a digital twin. I could spend a whole hour on it, and I have. But the really big piece, that's the word closed loop, and it's really connecting the physical data with the virtual data. So how do I drive back data that's in performance into the next engineering change or the next production change, so I can see that the simulation is going to work and the next revision is going to work, and I'm not doing too many changes, or I'm not doing it in an optimized way. Another big topic, and that this probably should have talked about first, is security. And there's any kind of security from a physical standpoint to a digital standpoint. And I think Chris said it earlier. OT and IT is that convergence which drives IIoT. And if you're not secure at the physical elements or asset, you have to be physical at the edge. So if you're doing high frequency data acquisition, you got to be able to show that you're keeping the right data and it's encrypted and in transit and at rest. You got to make sure that your cloud infrastructure is secure and built so that only you see the data and only people see the data you want them to see. Then when it comes to autonomous plants, we are a remote workforce, but the other piece of that I'd mention, I won't repeat what Chris said, but there's how's that machine learning? How is AI driving decisions and supporting decisions so that we make the correct one, even though we may not be there, or do we even need to be there? We'll just let the machine decide for itself what to do. And I'll just, this is not, I don't know much about the environmental piece on this, but additive manufacturing has been a huge trend for IIoT. and making sure the printers are doing the right thing, tracking them. And it's really a new topic, I guess I would say, and becoming a big trend I'm seeing. And then finally, people will say IIoT and they'll say IoT. I did want to make the point that IIoT is that industrial level scale. The machine is going to work. If you have an edge computer, it's got to be able to sit in the factory floor under vibration, underneath heat, underneath cool. And it's also industrial in terms of scale. It is not just how can I connect, my smartwatch and call that Internet of Things, because that is the Internet of Things, but we need to do this on an industrial scale with secure and safe and human piece of it as well. So then, on the key benefits piece, the way to read this slide is to kind of say, one benefit is, safety and security and integrity, like I mentioned, but really the result is that's protecting your investment. You are protecting the investment in the equipment. You're protecting the investment in your IT security infrastructure. You're protecting the investment in your people from a safety standpoint. So that's what you're really trying to do. It's great to do process optimization or efficiencies, but the real result is we want to be transparent. We want to outperform yourself, and you want to be able to prove that the real data proves that you're actually doing that. And then on the supply chain, how do we get alternative suppliers if one goes down or regulations change? You got to be flexible production, right? You can be smart in your logistics and adapt so that you don't have to worry about downtime or unexpected changes or unexpected quality. You can do the loss of, Chris, that was a really great point. There's an aging workforce. In fact, people are unfortunately not working as much as they used to, or there's jobs being let go. How do you reduce that cost? How do you look at that demographic change? And then make sure you have a flexible and open system that integrates not only new people, it integrates enterprise systems, any third-party data. If you're going to go connect to another database, you need to be able to do that. You need to be able to do it in a secure fashion. So that it's that outsourcing of services so that you can be confident that your data and your people have the right information to make the right decision. So let me turn that back over to Chris, I believe, and he'll walk through some more specifics on the environmental side. Happy to take any questions on that in the Q&A as well.
Thanks, Troy. I appreciate it, and well said, and reiterating some of my points and bringing up some of the other ones that I missed. I appreciate that. And one thing that you did bring up, which goes to the benefits on the pollution control equipment, is transparency. The saying, you don't know what you don't know, rings true here when you're talking about performance of a pollution control device. Essentially, things are running fine until they're not. And that really leads us into the second bullet point of improving uptime. Environmental technologies, whether it's a thermal or catalytic oxidizer, filtration control, scrubbers, whatever your technology may be, wastewater treatment plants, they're increasingly being tied to the permit and your process uptime. So simply put, if your air pollution control or wastewater treatment systems aren't running, neither are your production lines, which means you have a factory sitting there not producing product and not making money. In fact, many permits now won't even allow any startup for a shutdown or malfunction allowances. It's 100% tied into some of this pollution control. So knowing what's happening with your unit, it's not just in the backyard sitting there. It's a big capital investment. With the equipment itself, you need to make sure it's up, because that ultimately is allowing you to make your product or your service that allows you to keep running. So we routinely work with customers to set alarms on predetermined parameters to avoid production disturbances, but real-time failure alerts can also limit potential fines with regulatory agencies, which leads to our next point of simplifying compliance. I mentioned earlier that compliance is getting more and more difficult. The EPA has federal regulations here in the United States, but then you have state regulations. But even within a state, you have county to county for non-attainment zones and attainment zones. So it's a complex, and even us who deal with it on a daily basis, we don't know all the rules and regulations at times because it can vary from one county to the next. So things such as like electronic reporting and the centralized compliance documentation is going to provide you benefits that are sometimes overlooked as many of these agencies are moving towards electronic reporting. We have seen this trend continue to increase, and COVID has actually limited the regulatory agencies from getting to sites. So smart technologies also offer multiple data points should the reporting requirements change. For example, today, many agencies gauge compliance for a thermal or a catalytic oxidizer on combustion chamber temperature. We chart that, and that's really the only data point they need to know that they're in compliance. But in certain counties and states of the country, we're starting to see agencies increase those requirements. For instance, now you have to measure airflow, amp draw on your fan so we know that enough air is being pulled out of the system, pressure drop so that we know that we're getting good filtration and the filters aren't plugged. So IIoT will allow you to move quickly and adapt to these changes because any process value that can be observed and connected to a PLC, a programmable logic controller, can also be observed in this platform. The other point I like to bring out is a company's image has never been so valued as they are today on the corporate image and sustainability. So what are the costs to your organization of a blemish to that image? IIoT not only prevents incidents from happening that could lead to unwanted publicity, but the data collected could also protect the company image should it face litigation because you have all the data stored and you've been tracking it. If your company has, say, a sustainability policy that requires documentation, the data collection makes these smart technologies even more worth the investment. And then the other big thing is the benefit for, especially in the pollution control, is the efficiency. When discussing efficiency of environmental technologies, there's usually a destruction or removal efficiency, and that's dictated by the local and federal regulatory agencies. But then there's also what we refer to as an operational efficiency, which is how much is this thing costing me to operate, electric and gas cost or fuel cost. So automating these threshold-based changes to integrated systems will help you with both of these. So when maintenance teams are now alerted to destruction efficiency changes, they can begin troubleshooting. They can also notify the equipment suppliers because we can now assist in troubleshooting remotely by seeing the digital twin that Troy talked about earlier. We're seeing a real-time what you're seeing and can really support you remotely. And especially now, I keep referring to COVID, but getting on an airplane and traveling into a facility is not as easy as it once was. So being able to do this remotely is critical. And then the cost of operating these pollution control systems can actually eclipse the large investment that goes into it if routine consideration isn't given to the operating costs. So by regular reports on operating parameters can prevent costly energy bills. For those of you that take advantage of state or federal energy efficiency grants, IIoT can also help you achieve these goals and provide the proof to help you get the grant money. For a lot of utilities are now offering, with more energy efficient equipment, they will actually subsidize some of that capital cost expense. So the IIoT can give you some of that background information. Now, without a doubt, the biggest benefit to embracing IIoT for environmental technologies is the maintenance, which I've kind of touched base on. It starts with preventive. We've all heard the saying, if it isn't broke, don't fix it. And maintenance crews live with that every day on facility. A lot of rotating parts, you got pumps, you got burners, you got fans. There's just a lot of things that work, especially headed into the winter season, at least in the northern climates of the country. That even goes up when you start getting the cold weather. So by doing this in the IIoT, you can kind of eliminate some busy work for a maintenance staff that is already tends to be shorthanded by performing parts replacement based on usage data instead of calendar days. Using the data collected by this IIoT is allowing you to preemptively identify problems that are not discovered during or in between routine inspections. So what if you can reduce the time spent on routine inspection, saving valuable worker hours? You know that there's a cost savings and a return on investment with this IIoT that can be illustrated as you look at it. The next step from after preventative is then the predictive step. Now we take it a step further. The system can alert you and provide a script for action. At Angle, for instance, we identify replacement parts as convenient replacement parts, critical, recommended, or when needed. And some of these items come with long lead times. For example, you don't expect a 200 horsepower motor to go out or a primary pump on a wastewater treatment to fail. And so this isn't something you're probably typically keeping in your spare parts in stock. And these are also generally expensive and long lead time items. So with IIoT, you can extend the life of these vital components by monitoring its usage, and then you can plan for its replacement so it's not an emergency, which I touched on earlier. Uptime is critical. If something goes out and you can't get that part for a week, your plant cannot afford to not make whatever product it's making during that week. The third item here is prescriptive, and that's really true predictive is prescriptive with automation. Actually, Troy, we were talking, and a good example is that preventative is you're taking your temperature, for instance. It should be 98.6, and we're all taking a lot of temperatures these days, especially if you have kids going to school. So now all of a sudden it's 99, it's 100. Well, now I'm going to maybe go to the doctor. Okay, that's the preventative part. But the prescriptive is now the doctor is giving you the medicine, and so giving you the solution to how to fix the problem. And that's where if you go to the visual on the chart, we're trying to do this virtual world and real world. And it's kind of synonymous. It goes back and forth. So we're doing things that allow, in the real world, we're seeing on the virtual digital twin, and it just kind of goes back and forth. So I touched on the digital twin as Troy did earlier. He said he could talk an hour, but this is the ultimate tool for maintenance. Data in feeds data out. And it's a replica of potential and actual physical assets, processes, people, places, systems, and devices that are used for various purposes. As a pollution control technology provider, we're routinely asked, what would this change do to our process in the Angle system? And a digital twin takes the guessing work out of these critical decisions because we can now pilot these changes on the digital twin before we perform the work on the physical asset. And that's that chart. It's performance data, realizing, optimizing, it just goes back and forth. So it's a good opportunity there. So that actually leads us into, I believe, our next poll question, which I'll turn over back to you for Jessica.
Okay, thank you very much. And just a reminder before we go through the poll question to keep submitting questions for the speakers, because we will, again, be having a Q&A at the end of today's presentation. So the poll question, what are your primary reasons for investing in IIoT? Now, please select two: to improve uptime, regulatory compliance, plant safety, energy efficiency, enhanced maintenance, or supporting your staff. So again, please select two. Okay, and let's take a look at the results.
Okay, thanks, Jessica. So I'm looking at improve uptime, 23%, compliance, 38%. Energy efficiency is the leader with 53.8%, and enhanced maintenance are the top two, it looks like. So there's no right or wrong answer. Obviously, everyone has their own metrics that they're looking at. What's interesting here, though, the two that jump out, it kind of reiterates some of the points we were making. Operating pollution control equipment is not inexpensive between the electric and fuel costs. So optimizing that, lowering the overall cost of the facility is a good thing, which contributes to the bottom line. And then the enhanced maintenance, I agree with that one as much, because maintenance crews are spread thin. It's in all the facilities we're in. There's a shortage, and they're asking to wear a lot of hats between the engineering and maintenance departments to cover a lot of different equipment. So anything to support them, which kind of goes to the supporting your staff, will be a good way. So thank you for all responding so quickly and the feedback on that. So if I look at the air pollution control use cases, whether you're operating an oxidizer, a dust collector, a scrubber, a wastewater treatment system, all of these air technologies, at least, are designed around, what contaminants you're processing, what are the concentrations, what are the temperatures and volume that is coming to the unit. And the component integration that we can monitor and measure and then optimize, these are just a couple examples, but for instance, fan, a moving part on all of these types of equipment. We can monitor vibration and bearing temperatures, which will lead to better uptime. You have a bearing failure and you're notified way in advance, you can take proactive measurements to change that out at the next shutdown, or at least have the part on hand if it goes down. And that goes back to the poll question, that uptime is one of the top things. Another one would be burners, fuel to air ratio. Is it optimized that we're not burning excess fuel if not need to? Also going back to your poll answer, the top two of operating efficiency. On the filter type system, whether it be bags or cartridges, we can measure pressure drops, which will lead to when does the filter need to be replaced, rather than just a mechanical gauge and having a maintenance person going out and checking it. We can help on continuous emission monitors to meet compliance or temperatures. And there's just a whole host of, look at heat exchangers, whether it be on regenerative units with ceramic media or metallic heat exchangers for plugging, degradation. Look at thermocouples, valves, sequencing, number of times the valves move, number of cycles, and gas meters, electric meters. So there's just, it's endless what we can monitor if the equipment's there and support the companies that you and your workers on staff. In the case of industrial wastewater, it's very similar. Variables include temperature, volume, discharge contaminants. We're trying to get removal efficiency. And in this case, we're looking at filters, tank levels in tanks we can be monitoring, the pressures of the pumps, variable speed drives, chemical dosing. Ultimately, our goal is trying to improve the service, the uptime, and reliability. Third opportunity is, soil and groundwater remediation, which is kind of a mixture of air pollution and water abatement. And monitoring and measurement is particularly valuable on remediation applications because the equipment's often located in remote, unmanned locations. These satellite locations require travel, and you got to ask yourself, what does it cost to get someone to drive 3 hours, get the data collection, do the maintenance, system checkups? Now he's there, and you don't have a part. Now you can be troubleshooting from afar. And in addition, flows and concentrations change over time as site is cleaned. As remediation sites, whether it be from an underground storage tank leaking or whether it be from an old factory that has dumped solvent into the ground and gotten into the groundwater, things change. So it's a continually dynamic piece of equipment, and so these make alerts particularly valuable for turning soil and water remediation systems, whether it be extraction blowers, pumps, the oxidizers, scrubbers, knockout pots. So there's just a whole host of opportunity of where this technology can be used. So with that, let me send it back to Troy to talk a little bit some of the challenges, though, that we have to overcome in IIoT.
Appreciate that, Chris, and I'm learning a lot while we're going through this. This is awesome. we've talked benefit, we've talked trends, we've talked the approach, we've talked benefits and use cases. I just want to spend a little bit of time about how do you get started. That's one of the biggest things people try and address with me. Where do I start, and what's the challenges? What do I need to look out for? So I'm going to go through the challenges just quickly that I see quite a bit. And a lot of it is around, there's already existing equipment. There's very few greenfield startups that aren't already considering, an existing approach. So we find people have proprietary systems where they're using closed protocols, or they've got closed hardware, or they've got legacy applications. They might already have a legacy data historian that they want to connect to, and all this old data. So how do you get started? Where do you know where to start on that? They have on-premise infrastructure. They might have invested in a large, their own data center, or they've already got a bunch of servers sitting around. They've got existing sensors and existing edge devices. How do you start with that? And then we find a lot of people have piecemeal solutions because they're trying to get some of this data from proprietary or legacy applications. And piecemeal is bad because you can't really see the whole puzzle, right? You just get to see a piece and then someone's probably got some fancy Excel sheet where they try to do a bunch of calculations to do algorithms on top of that, and it's really not a sustainable approach going forward. So you got to figure out, the very first part is figure out where you want to start. What's the faster ROI? Is how I would, that's what you want to consider. What's my easy win to go forward? These piecemeal solutions, like I said, they may not also meet your customer needs or specific customer needs. We see that a lot where they've put a bunch of things together and didn't really think about what's the outcome that I want? What's my specific need? Do I want to approach OEE, or do I want to approach throughput, whatever it happens to be? And we've talked a lot about meeting stringent security and compliance requirements. And I certainly see that from on a global scale. Chris can speak to the environmental piece, but when you're talking data security, what's the regulations of data in the U.S. versus classified data versus GDPR data in Europe? You got to make sure the system can scale across those and meets all those requirements on that back-end infrastructure, not just meeting the AMP draw, which I don't know exactly. I guess I kind of know what that is, but those are two different kinds of compliance requirements. You have compliance on the data itself, and then compliance that machine is going to run at. This one I see a lot too. People are already operating a proprietary closed applications. They may have on-premise infrastructure, but it becomes proprietary, and they've hired a bunch of developers or consultants to develop their own application. And then in the end, when somebody leaves in 5 years or 10 years, you got to either maintain that application, pay somebody else to come back up, and then maintain that infrastructure as well. And that is really a big cost in terms of time, money, and people. And then you've got to be able to broadly use the data. And I say that in the sense of, yes, we want to collect and we want to connect and use AMP draw data, but it might be interesting to see, put that into geographical data, right? Integrate the data systems, weather data, operator data. How do you combine all three of those easily to draw new insights and new context that might help better optimization? So how you get started? I put ideation in there because I think people understand that word quite a bit, but it's really co-creation. There's a partnership you got to develop. You work with somebody who, one, has the right stuff, whether it's a digital twin, whether it's a open, flexible ecosystem, whether it's can you connect to all the systems I need to connect to. There's really a co-creation piece. And you'll see on that slide, this is, there's a curve here. We call it a maturity curve. And you really start going through it. The very first thing is, let's go connect and let's monitor, right? And just have some kind of idea of how things are going and get the data. And we have some 6 months of data, 3 months of data, whatever it happens to be, we can run analytics on it. And then we become predictive. And this is really, Chris, I liked your story. I always say, like, if my car would tell me to change its oil in 10,000 miles, I definitely wouldn't change it every 5. I'd like my car to tell me exactly when to change the oil. And then finally, you get into a digital transformation where we're really doing this connecting of many more data sources, many more plants at a scale where I can get real analytics. In short, it's a journey, right? It is not just, hey, we turn the switch on day one. There is a partnership that starts, and then you start working piecemeal to get maybe one line, maybe one factory, and then learn from that, and then get real fast ROI first, and then scale that across your operations. So I hope that's quick and easy. I want to make sure we have time for question and answers. I'm happy to address any of those questions and answers. I want to give Chris some time here to send us out with a couple more slides.
Great, thank you, Troy. And I'm probably touching base and repeating some of the things you said, but a lot of what you talked about are the key features and considerations for the environmental technologies. So if you look above here, this is a sample screen of a client with a regenerative thermal oxidizer, but has multiple data points. So if I start out with the simplicity, it is very important, especially during the initial phases. I talked about complexity. It is complex IIoT, but we start simple, and then we build through that journey that Troy talked about. And the sample screen, they're measuring some simple data points, but then they're using condition-based alerts and help them make complex, important business decisions. Troy, you just talked about security, but on the environmental side as well. Data protection is important, but we're also a potential link into their facility, so they're trying to protect process knowledge, and this is all built into the offering. So it's a secure, robust, industrial scale technology, and it's got to be flexible and scalable. Businesses change every day. Our company's been in business, over 40 years, and it continues to grow and change annually. And so you have to scale up, scale down, and so this is not a set it and forget it. This is going to be an ongoing thing that continue to learn, continue to improve, and hopefully give you the metrics to make good business decisions that is going to help you in the long run. And it's got to be industrial, and Troy did touch on this as well. This is not an off-the-shelf commercial product. This is built for an industrial, robust application. We all know that the floor of a factory is a lot different than sitting in our office. There's a forklift can run into things. You got cold temperatures, hot temperatures. Potential of liquids being things. So everything we live in this world every day, and so this is an industrial, reliable, robust system that can offer and is really going to help you in all types of industries. And then the integration is important. You don't have to have an Angle system to use this, or a Siemens PLC to use this. This is going to be able to communicate into your ERP, into your programming, if you have SolidWorks or CAD or a DCS system or SCADA. It's regardless of the manufacturer. This is designed to support that type of equipment. And when you do start, don't go at it alone. You want to get input from multiple stakeholders, whether it's be the machine operator themselves, the plant manager, plant engineer. What are their requirements? What about your supply chain and key partner? How is this going to affect your customers? You want to get them involved because you want to offer the most bang for your buck, that when you do invest in this IIoT, that you're going to keep your customers happy, keep your plant happy, and like I said, there will be a return on investment from a profitability is what you're really looking to get at this as well. So that kind of wraps up where we are, and before we jump into the questions, I guess in conclusion, IIoT will really continue to play a greater role in industry. And as shown above, we're trying to improve transparency, make educated decisions. And then in the environmental side, you're trying to simplify and lower cost of the compliance with the regulatory agencies. This is the wave of the future, and though it is complex, you can start simple, and if you embrace the IIoT, it's only going to help your company move into the future. So with that, Jessica, I guess I'd turn it back over to you if some questions have come in, or if you want to do any other wrap-ups before.
Great. No, I appreciate it. Thank you, Chris and Troy, for a great presentation. I'm actually going to start off with a question that I actually have, and it's what is the biggest hurdle that you see working with companies in terms of getting the buy-in for the IIoT?
I can start on that, I guess, Troy.
Yeah. I'll let you start, and I've got an opinion on that too.
For us, and it's something new, and it's the unknown. They know the terminology. I think you use the Apple Watch or the smart watch, as an example. That's IoT, but the industrial is different, and how is it going to help them? So we, as a company, have to go out and demonstrate that, and we've piloted with customers, we've taken polls with customers, feedback, what are they looking for. So it's an iterative process that you're trying. I'm not trying to sell you a product, because everyone's really somewhat of a custom solution, and even for us to embrace it, to Siemens' credit, that's why we partnered with them. We had to get involved with them to understand that we had the robust background and support that Siemens brings globally to support our customer base. So a lot of it, to me, is just like you said. It's the unknown, and it's all custom built to solution per plant, per factory, per company. I don't know if you want to add to that at all, Troy.
Yeah, I still think, and it just kind of comes up to people are, you said, the unknown. I think there's people have fear that they have to do it all, right? We have to be able to connect everything all at once, and then it's like, how do I connect? And then how do I get a sensor on some old machine that's RS-232? It doesn't even have a network. There's always these concerns, and all of a sudden it all boils up in your head. You get too confused, and that's really where that co-creation and the partnership kind of comes together, where you're trying to put an idea. What's your KPIs you want to measure? What's the outcome for the business that we want to achieve? Identifying those things up front really drive a good product and process at the end. And there's just a fear of I don't know where to start or where to connect.
Which definitely makes sense. So I appreciate both of you taking your own perspectives on that and kind of tying both of them together. Our next question has to do with small businesses. What are your thoughts on the unique opportunities and challenges for small businesses?
Well, we probably fall into that cat. Go ahead. You start, Troy.
Yeah, so I'll start with that one. That one actually is it's an interesting question. And I think the main challenge comes in with some people think that, they got to go buy a server, they've got to go, have some, IT to either contract out, or I got to go hire an IT architect. I got to get, somebody to plug this all in and do software. I got to get, all this stuff. And that's the scary part for small businesses, because there's a lot of upfront CapEx that goes into that. Which is why when we look at platforms on the cloud and IIoT, that it's an interesting proposition to a small business, because there's really no CapEx going forward, and then you can scale up and scale down as Chris mentioned as the business goes. So I think that's the interesting prospect to a small business. The challenge is they think they got to go get all this infrastructure where really you don't, or you don't have to get. I'll speak to just any kind of regulations from the auto side, that a lot of companies think they have to go get somebody who understands, all the regulations that GM puts on versus what Ford puts on versus what FCA puts on, and the small business wants to be able to go, I want to do this. This is what I'm really good at. I may not be good at developing analytics. I need to find someone to partner with.
And I'll echo that. A lot of our customers are small customers, small clients. That we, there's Fortune 100 companies, and then there's single facility locations. And it just echoing what Troy said, it is not a huge investment. It's more of partnering with them. Siemens has a robust, with Anguil, a platform that can support it, and it becomes almost of a subscription type service. So it's more of a fee-based versus a large CapEx investment, which we can support.
Got it. Thank you very much. And just to kind of piggyback on that, and it might be hard to answer this specific question, but what is the typical timeline? And I know there are a multitude of factors that come in place here, but what is the typical timeline from a company, contacting you, Chris, to say, like, this is what we want to work on, what can you do for us? And then from the time that they contact you to having a system up and running, what does that usually look like?
That's going to vary. And I can show you, what we've done thus far is, we start with the client, and like I said, it's an iterative process of back and forth. What are they trying to gain? What we think we can offer them, whether it be our equipment or someone else's equipment. And you kind of go back and forth in a question and answer, and then you set up what are your goals. And then through the goals, that's usually, it's not a week we're going to turn this on. It's a 3 to 6 month process of getting this set up. And then there is sometimes some hardware that has to be installed in the control panels, and we have to, put that on the equipment so we can read the data and bring it back in. But right now we're probably looking at a 3 to 6 month timeline from starting to, operating and truly gathering that data.
Great, thank you for that. Our next question, and this is an interesting one too, is we obviously know regulations change. They can change year to year or depending on administration. So with air and water regulations always changing, how do you see the IIoT adapting to these changes?
Well, that's what's nice. What we've talked about is the flexibility and scalability. Once you put a system in, for instance, and you're monitoring, say, a dozen data points that you're required to, and now the new regulation comes out and says you need to do X, Y, and Z. I don't need to put a whole new system in. This is scalable. So now I can add maybe some more monitoring equipment, some more sensors. We can put that in and retrofit it, and then it uses the same platform. I don't have to start over. And so that's what's really nice about this is I can start with X, maybe 5 things I'm monitoring and get up to 20, and then maybe I get up to 100, at some point. So as regulations change, this is a very, very flexible system that could require some hardware. I don't want to say because it's not all there at first, but it should be able to move with the regulations.
Which is always fantastic. And this next question definitely plays on to the last one that you talked about with older hardware, outdated machinery. So how hard is it to incorporate older, outdated hardware machinery to an up-to-date IoT system? Is it really just based on what you go in there and see, or do you have a set of systems that you can catalog that work better with your system?
I'll step in here just as a quick example. As an interesting point, it's not necessarily an environmental with AmpDraw, but we were with a customer and they had an old conveyor belt system that they wanted to measure the vibrations of the rollers, so they knew when to change the roller out. The simple solution was as easy as getting a little $5 Bluetooth sensor that was $5. You put it on each bearing, and then connect it to the system, and then you got the data. Right? It can be very simple. It doesn't have to be just machines and stuff like that. You can start monitoring other things relatively quickly. And in that case, it's really cool because if the sensor breaks, it's only $5 to replace. I don't know if that applies to you for everything you do, Chris, but that's
absolutely.
We do connect to those legacy systems. You just you got to go look at it, I guess.
Right, and I think it does come down to looking at what the facility has. It's not that I have to change everything out. It doesn't have to be a Siemens or Angle product for us to support it via this IIoT platform. It can be made by company X, Y, or Z. Maybe the company's not in business anymore, so you can't get service support. We take that on, and once we start collecting the data real time, and it may require some instrumentation adding. I don't know if they're always $5, but I'll buy those too if it's only 5. But it's something that can be done, and if there's a really outdated, now it has no connectivity, we'll address that. Maybe that's a point we do have to look at. But it's surprisingly, with some of the sensors, monitors that we can add to old legacy equipment, we can start gathering trends, metrics and data to allow, educated decisions going forward and ultimately lead to improved uptime and compliance.
Great, thank you. We really do only have time probably for one or two more questions before we wrap it up today. So I thank you attendees for submitting the questions for today's event. Can you guys elaborate on how to avoid using proprietary closed applications?
I'm sorry.
You had jump on.
I don't think I caught it. Go ahead, Chris. I don't think I caught it.
Go ahead one more time. Can you repeat that, Jessica?
Of course, yes. Can you elaborate on how to avoid using proprietary closed applications?
Yeah, sure. So I guess I'll just give an example. You want to make sure when you're looking at any system, I guess I'll argue, I'm open by nature. And Siemens is open by nature. So that it's the other way around would be to say, you're going to go get a Siemens sensor. You're going to have to get a Siemens PLC. That's the only way they'll talk to each other. You have to go get a Siemens edge controller, and you have to go connect to the Siemens cloud, right? Or in this case, MindSphere. That's enforcing that, right? You want to avoid. You want to be able to say, hey, if you're evaluating when you're evaluating a system, can you connect to my my other machines, my other PLCs? Can you connect to my other database or enterprise systems? It's really asking the question of any particular vendor, what's your connectivity? Do you have APIs? I mean, that's from the pure software and infrastructure side and hardware, because some protocols, they force you to use a certain protocol, and that's not always good because then you're kind of stuck.
And that's one of the reasons we partnered together to do that. Like Troy said, it's not a proprietary system. It's accessible. We're going to bring the customer into the platform. They'll be able to look at it real time, just like we are. And our hope is that we are like another service body on your site, and we're just here to help the customers. And this system is not proprietary from the standpoint that you bought it and all of a sudden you stopped working with it. It's okay. You got to rip everything off the machine. That's not our goal. And as Troy mentioned, the fact that these work with any type of PLC, different manufacturers of all types of equipment, it doesn't have to be just our two companies.
Which I do appreciate you letting the audience know that, because that was a question that did come in, how you can integrate this technology with the system that's not yours or Siemens. So I do appreciate you touching on that. I know, Chris, that before we started the Q&A, you kind of summarized a little bit for us the presentation, but before I wrap it up, if you and Troy could give the audience 2 to 3 takeaways, big takeaways from this event, that would be great.
Troy, you want to start on that, or you want me to?
Yeah, let me start first, and you can finish, Chris. I guess I would say the biggest takeaway is you have to embrace complexity, and complexity is going to be forced upon you whether you like it or not. So embrace the complexity and use it for an advantage, and take that forward to your customers and your business. Don't be scared of complexity. Embrace complexity.
Yeah, I'll second that. I mean, this is the wave of the future. Having people on site, you need the support, and this is only going to help your bottom line, your productivity, your reliability of your machine, and it makes ultimately your customers happy. It's overwhelming at first, but when you really dig down and break it down into pieces, you don't have to go from 0 to 100. You can take baby steps as we go down this path. And like I said, we're dealing with Fortune 100 companies in single facility, and they're embracing it. And ultimately, they're going to see the return on investment of going down this road.
Well, thank you. I want to thank you, Chris and Troy, again for a wonderful presentation. I want to also thank Chris, your team, who I've had the pleasure of working with for a while now, Kevin and Mary, who work behind the scenes. I always enjoy working with them on all of our projects. So definitely a big thank you to them. I hope everyone has a wonderful rest of the afternoon, and I hope everyone watching this on demand enjoys it as well. If you watch this on demand and still would like to contact one or both of the presenters. Their information is on the presentation bridge, so feel free to contact them at your convenience. And at this point, I'm going to conclude today's webinar. Have a wonderful afternoon, everyone.
Thank you, Jessica.